Hi, I'm Thomas Moulden,
Hi, I'm Jack Pearse.
And I'm Caden Getek.
and this is our Engineering Development and Design final presentation. All right, so identifying a problem. So after a lot of brainstorming, we come up with various different problems that could be solved. However, some problems proved to be better than others. The problems we did not select to pursue further were either too broad of an issue, were not really an issue to begin with, which means they lacked a lot of the ability to be justified, or they would prove to be too difficult to solve. Here's some examples of those problems we did not pursue. So for carpal tunnel syndrome causing pain and discomfort, we kind of X that immediately. We said that it was too broad of an issue, too much research required, and it already is being addressed by a lot of experts. Liquids do not flow out of blender bottle as fast as we would like them to. We X that too. We said that it's not really an issue because there's not really any justification. No one really thinks that it's an issue. Expired milk causes discomfort when accidentally ingested and wastes money. We X that too. We said it's not really an issue. There's once again lack of justification, and it'd be hard to develop an effective solution. Is what we found. But kayaks tip over too easily and cause injury and lower confidence levels for users. We like that problem because it can be justified easily. There's many easily developable solutions, and we all had some personal experience, kayaking and being on the water. So moving on, after we had selected the problem, in order to pursue that further, we needed to justify the problem. So that means there'd to be actual evidence that many individuals had found that to be an issue. So what we did was we created a survey, and we refined the questions on the survey many different times, and we distributed across both Reddit and Facebook, and it received in total 112 responses. And of those 112 responses, we had a wide range of both ages, genders, and the kayaking frequency, and just all the different data. And that means the data could be used confidently to justify the problem. And what you're seeing on the screen right now is where we found that in our responses. So on to detailing problems. So we had the issue that kayaks tip over too easily, but we needed to refine that. And we need to create a fully detailed problem statement. And a complete problem statement answers the following questions. What is the problem? Who has the problem? And why is it important to solve, right? So we start with kayaks tip over too easily. Kayaks tip over too easily and can injure and cause injury and lower confidence levels of users, right? And the next one, we said the kayaks tip over too easily while users are entering and exiting the kayak, and this can cause injury when the user falls into the water, and the possibility of tipping over can also lower the confidence levels of the kayakers. And then, after getting the whole survey, we pieced it all together. We said kayakers can feel unstable while getting in and out of kayaks due to lack of support in and around the boat. The lack of support can cause kayakers to fall in the water and possibly injure themselves. Approximately 40% of the surveyed respondents stated that the instability gave them some sort of degree of difficulty. So moving on, now that we have our problem, we looked at previous solutions. After creating a problem statement, we need to review the previous solutions, and we need to draw from the successes of the previous solutions and then address the pitfalls of them. So here's a product. It's a kayak launch dock, and we found that although it was good at getting people in and out and providing some stability, it proved to be really costly and was only able to be used when people were entering the water like on a shoreline. All right. Then we also looked at patents. So for this patent, it would be inflatable tubes on the side, but we found that this would rely on the kayaker to blow up the tubes, and it just proved to be ineffective in a lot of different scenarios.
So after reviewing some of the previous solutions, our final design requirements were put together, and we said that we need to ensure that the solution addresses these specific problems and lead to tangible and viable solutions to the problem identified. We're all remaining objectively reasonable in order for the requirements to be objective. Each point needs to be measurable. So while brainstorming solutions, these requirements that we laid out on this slide, we feel that they need to be addressed. The final design for us should address most, if not all, of the points on this list. So here we went over a bunch of different design solution that we came up with on our own, and each of us came up with 2 different ones. So the first idea that we have here is sort of a slot where you would park your kayak into. It's kind of very similar to the first previous solution we came up with, but we think that this solution type would be more cost effective. Our second idea would be a like inflatable ring around the kayak, but this one would instead be like permanently inflated instead of having to be inflated by the user each time they want to use it. Another idea would be sort of these legs that you'd attach to the kayak that would be able to fold down and add stability in shallow water. Another idea was a sort of hook and rope system that you could use to dock your kayak, sort of like a boat. And our other idea would be to use these paddle hooks, which would be able to hook your paddle onto the dock while entering and exiting the kayak, or hook it onto the kayak itself, and so give yourself some extra stability there. Our last idea was the centerboard kayak, and so this idea was one of our first ones we came up with, and it basically involved adding a centerboard to a kayak that was retractable in order to still be able to go into shallow waters, but to add stability while entering and exiting, and also while using the kayak. So for here, we have our decision matrix. We use this to go through our different 6 ideas and compare them to the current solution of just the standard kayak, and see how each of our ideas would affect these different criteria throughout the design matrix. We went through and decided that ease of use, mobility on land, and mobility on water, transportability, weight, footprint, stability in use, and stability while entering and exiting are the specifications we wanted to determine from this matrix and see how each of the design affected that. We also weighed each of these things differently depending on how we thought they were important or not important to the thing, but because we included them, they were all at some level of importance. And so for this, we decided that actually our number 2 design came out to be the strongest one with the centerboard, just because we liked some of the features and we thought it was a little more doable than the inflatable ring design. And so that's why we chose that one.
All right, so on this slide, we show our final design solution of the centerboard of the kayak. So after we decided and went through the decision matrix, we decided that because of how efficient it was, and it didn't really like affect the kayak shape and everything, like with the extra width, that it was pretty tangible to do and was easily like achievable. So here we see the front view of the centerboard where, like as if the boat was you were looking straight at the boat. The top view, you can see where like the centerboard would be located compared to the kayaker's feet and legs, and then the side view is shown where it would be when it's retracted all the way up, and also where it is when it's all the way down in the water. So here we have the CAD modeling of our centerboard. As you can see, the kayak would just be a pretty standard kayak, except for in the middle of the boat, there would be a centerboard. And there we can see the animation of how the rudder would drop down, and it would be easily retractable into the boat. So design solution viability, basically this is why we think if we were to create this project, why we'd be able to have some success in the market as today. In the United States, there are approximately 225,000 kayaks sold per year. So that just shows that people are always buying kayaks, and there's just always like a need for some more, like a better kayak. And then a lot of the market of like the stability options are only for beginner options, or like beginner level kayakers. And so our centerboard would be able to be used for a range of skills. Um, so, and a lot of the cases that the options like created by other people reduce the cost up front as well as ours. And then our solution also makes the learning process a lot easier while using the kayak. So our product overall is just better for new consumers of kayakers, and where the market of kayakers keep growing, there's always a need for a much more easier way to learn than just going straight into it. All right, and so for us to like give our design weight and like credibility, we ran 4 different tests on them. We decided to test the mobility on land, the mobility on water, stability while in the water or in use, and then stability while entering and exiting the kayak. To test the mobility on land, we would measure the additional weight that the centerboard adds to the kayak. If it is more than 10 pounds, it has failed to meet our design specifications and therefore has failed to test. To test the mobility in the water, we will compare the ease of completing a turn in a normal kayak to the one with the centerboard. And that way we can just justify saying, hey, it doesn't impede any sort of normal kayaking, but it also gives you the stability while being in the water, and it's just a lot safer. The stability in use, along with making sure you don't tip over, obviously, we want to measure the angle that the kayak is able to tilt. If we, in our design specifications, we wanted the kayak to be able to at 45 degrees instead of 40. And so if the kayak can go to 45 degrees, then it would be unable to fall. And that has met our design specifications. And then stability while entering and exiting the boat, what we would do is we'd set a timer of someone getting in and out of a standard kayak and compare it to the time of someone getting inside of the same person getting in and out of our centerboard kayak. And that way we could have quantitative data to compare the two and really justify why our design is better than the other one, than a standard kayak.
All right, that's the presentation.
Yeah.
Okay.
That's our whole semester.
All right.